Okay, this is an attempt to solve this Leetcode problem, which is based on dynamic programming. So here's the question. You're a professional robber planning to rob houses along a street. So the problem here is you cannot rob two adjacent houses, as in if you have, let's say, 1 and 2 and you want to rob both of them, then what happens is it will automatically contact the police if two adjacent houses are broken into on the same night. So for this, what we'll have to do is we'll have to choose between 1 or 2. So if you choose 2 here, then it is not possible for us to choose 3. So we'll have to either choose 1 and 3 or 2 and 1. So 1 and 3 will give us an overall output of 4, which is the solution here. Similarly, if you try to solve for this, then you can either rob 2, 9, 1, or you can rob 7 and 3, or you can rob 7 and 1, because if you choose to skip 3, then you can choose that, but that's how it works. So let's try to understand how exactly we can solve this problem. Let's consider this example. Let's consider we have only one house. So in this case, what is the output? It would be 1, right? Let's consider we have two houses, 1 and 2. So what is the best possible output right now? It should be 2. Let's consider we have only 1, 2, and 3 until here. Then what is the best possible output? We can either choose between only 2, or we can choose between uh, 3 plus 1, right? So 3 plus 1 is a better output right now. So let's choose 4 here. And if we have 1, 2, 3, 4, and 1, then the best possible output we can have is either we can choose 4 directly, or we can choose 1 plus 2, right? 1 plus 2, and the output will be 3 or 4, and the best output that we can choose here is 4. That's the uh, answer we're looking for, right? So let's look at another example here. 27931. Okay, so let's consider we have only 2, then 2 would be the output. If 7 is also present, then 7 would be the output. If 2, 7, and 9 are present, then the best choice we have is 9 plus 2 or 7. So it would be 11. And here the best choice that we would have is this is or uh, is either 3 plus 7 or 11. Uh, so 11 is still the best choice here. And the best choice we have here is 1 plus 11, or the best choice so far is 11. These are the two choices we have, and 11 plus 1 is obviously greater than 11, which is 12. That is the response. So how are we choosing this here? So let's consider if we have only one choice, then uh, dp of 0 is the output. So dp is simply an array. Let's assume we have an array of size exactly matching the input array. So let's assume 0, 0, 0, 0, 0. This is an array. So dp of 0 would be equal to array of 0, and dp of 1, it would be, we have only two choices here, array of 0, uh, maximum of array of 0, and array of 1. These are the two choices we have. So here it can either be 2 or 7. So in the previous example, it can either be 1 or 2. So in both the cases, it was actually equal to array of 1, but if 7 and 2 are reversed here, as in the previous example, if 7 and 2 are reversed here, then both the responses should be 7 here, right? If there's only 7, then 7. If 7 and 2 are present, then uh, still we would be choosing 7, right? Now let's consider the third one, dp of 2. It would be equal to uh, dp of 2 plus dp of 2 minus 2, which is equal to 0, or dp of 2 minus 1, right? So with this we can simply deduce a formula which would be something like this: dp of n is equal to dp of n plus, sorry, array of n. This would be array of n, array of n plus uh, dp of, as in the previous best choice here, n minus 2, comma, maximum of dp of n minus 1. So this is the formula. Let's simply try to run this formula through, and the output would be dp of the maximum one. Let's try to execute this and see in our program. So this is the question. It's the exact same question. Let's try to execute this. So first let's initialize a dp, and then let's simply say dp. So length, if you see the constraints here, it says length can be between 1 and 100. So it can be 1, 2. So if the length is 1, then what would we do? We would simply return, and the numbers can be between 0 and 400. So there are no negative numbers here. I mean, a house cannot have negative amount of money in it, right? So we would simply return nums of 0. If that is not the case, then what would we do? We would simply say dp of 0 is equal to nums of 0, dp of 1. We know that 1 exists here, right? Because length is already greater than 1 here. Because in the earlier case, we were returning it. Okay. And now what we can do is, from 2, I less than nums dot length I plus plus. So if the length is 1, what happens? It simply doesn't enter into this for loop. So that's not a problem at all. And we would finally want to return the output at dp of nums dot length minus 1, which is the last index, right? Or we can simply say dp dot length minus 1 as well. That is both one and the same. So right now, what do we need to do? dp of n, or I in this case, let's make it n because we've written it as n. N is equal to nums of n plus uh, dp of n minus 2. So if n is equal to 2, then n minus 2 would be 0. So it doesn't fail uh, this condition. And dp of n minus 1, right? This is what we were trying to do, and let's try to run this. Okay, I forgot to add. What again? Okay, I've changed it to n from I, so that's the reason this has come. Okay, again. Accepted, and if I submit this, all test cases passed and it beats the 100%, uh, which is generally the case for this problem. But let's see the memory. So if you see memory, it beats only 25% here. That's because what is the time complexity for the solution? For the solution, the time complexity would be O of n, because we are running through each number only once. And uh, the space complexity. The space complexity is also O of n. Can we reduce it? We are actually using only the previous two numbers here. So can we reduce it? Let's try to do that right here. Right? I'll just comment this, and instead I'll have int uh, n minus 2, n minus 1, and n, three values. So I'll just, so this is n minus 2, isn't this? N minus 2, n minus 1, and this will be n. Nums of, okay, the naming convention again will hit me hard. I'll just make it num. It'll get extremely confusing if I do this, so I'll just name it as t, t1, and t2, right? Let's make this t2, and let's make this t1. So t is equal to nums of n plus dp of n minus 2. What can I replace this with? Simply t2, and this one with t1. That's it. And what else is happening? So automatically T1 and T2 values are being updated, right? So T2 will now be T1, and T1 will now be T for the next iteration. And do we need to do all this? I mean, the return statement is also changed. So right now, even if we get the T value, that will obviously have the answer, or we can have the T1 value, which is absolutely same as the answer. Let's try to execute this first. Okay, T is not initialized, so let's initialize it to 0. And it's actually better to return T1 or either initialize t here. This is better because for the case where there are only two elements, it would obviously fail. Okay, let me try submitting it. It's passed. Beats 89% right now, and that's something that we shouldn't be caring so much about. But here the space complexity is O of 1 because we have a fixed number of variables. No matter how large the size of the array is, of course, there's a description saying the length can at most be 100, but even if it goes to lakhs, our memory footprint would be only these three variables, the additional variables that we've added. So that's it for this problem right now. Thanks for listening.